Alright, so we're going to express the product of each of these expressions as a fraction. Just to identify the word expression, it means an expression is a collection of numbers or variables connected through operators, meaning plus, minus, times, division, squaring, anything that requires you perform an operation. So 2 times 3 is an expression. Alright, so you should all know 2 times 3. 2 times 3 is 6. Alright, so let's take a look at that as fractions. 6 times 1 is 6 over 1 is equal to 2 over 1 times 3 over 1. Now this kind of appears similar to what we said for adding and subtracting fractions. 2 times 3 is 6, and then we could leave the denominator the same. Is that true? I don't know yet. We'll have to find out soon. We definitely see a direct connection between the numerators. 1 times 1 could be 1, so it could be that we actually do use these. Let's take a look at that in a moment. But let's take a look at the number line and how we can use that to confirm our suspicions a little bit. So just like with addition, we could start with the first number we have, and to multiply it by 3 means, oh, we also need 0 on here. 0 is important for this. Alright, so this is the distance 2. Alright, so 2 times 3 means to have 3 groups of 2. So this is one group of 2, another group of 2, which is at 4, and another group of 2, which is at 6. Alright, or to add the same group to itself 3 times. 2 times 3 really means 2 plus 2 plus 2. Oops. It also means we could do it in reverse. If this were 0 and this were 3, and this distance was 3, this would be 2 groups of 3, meaning to go 3 there, and then to go 3 more, which would also end up on 6. Alright, so that'll explain the commutative property when we take a look at that in a little bit. Whoops. Trying to do undo, not z. Alright. Alright, so what's 2 times negative 3? So let's take a look at that. This makes a little bit less logical sense. So if we start at 2, and 0 over here, actually let's put the 2 over here, and 0 here. Okay, what's 2 times negative 3? Well, that means to take 2 and make it negative, so that'll move it over here to negative 2. That's one thing that happens when you multiply by a negative. It reverses the number. So this is going to switch to here. Okay, and you have 3 groups of it. So this is one group of negative 2, and we have 3 of them. 1, 2, 3. So that's negative 6. And just like before, we see the same connection between the numerators as before. Alright, so let's take a look at the other direction. We're going to start at negative 2 and multiply that by 3. So we have a direction of negative 2 already, and we're going to have 3 of those. 1, 2, 3, negative 6. So when you multiply by a positive number, you're adding it to itself multiple times. If you multiply by a negative number, you reverse it and then multiply it by that many times. So this is negative 6 over 1, 1, 1, same thing. Alright. So we should see that when we multiply by a negative, we reverse the number first, then multiply. So if you multiply by a negative number, the sign will change. In this case, we multiplied by a positive number, the sign did not change. We multiplied by a negative number, the sign did change. We multiplied by a positive, did not change. So based on that, if we multiply negative 2 by negative 3, we should get a positive number. Now let's take a look at that visually. Alright, we'll start with 0 on the number line, 0 here. We'll put negative 2 here. By multiplying by -3, first we reverse the sign, so that's 2, and then we multiply that 3 times. So first we have to reverse the sign, that's the negative part, and now we do 3 of those. 1, 2, 3, so that's 6. Alright, so this is the basic rules we might have noticed. These are the sign rules, and they apply to multiplication and division. When both numbers have the same sign, their products will be positive. That's because when you multiply by a positive number, the sign won't change. If both of their signs are negative, such as in this case, the negative number will be reversed by the other negative, becoming positive. So if both of them are the same, we get a positive result. If both numbers have different signs, their result will be negative. Let's take a look why. So we have a positive number, make it negative, it becomes negative. If we have a negative number and don't change its sign, it's still negative. So 2 positives make it positive, 2 negatives make it positive. 1 of each make it negative. Alright, so it appears to be that we multiply the numerators and multiply the denominators, but let's confirm that with another example. Alright, so firstly, this is less clear because these are not written as fractions. What is 5 times 0.5? Well, that's a half, or 5 times a half is 2.5. Let's write all of these as fractions and see if this makes more sense. That is 5 over 1 times, we're going to use the dot instead of x on a regular basis because x is going to be used as a variable often, so we're not going to confuse ourselves. So I'm just using it early on just because it's something you're familiar with. 0.5 is 1/2, and 2.5 as a fraction, that's 25/10. 5 goes into each of these evenly. 5 goes in here 5 times, it goes in here twice. So that's the equivalent fraction if we divide both of those by 5. So that's 5/2. So let's see if we can see a connection between the numerators and denominators. 5 times 1 is 5, and 1 times 2 is 2. So the rule for multiplying fractions appears to be to multiply fractions, multiply their numerators and their denominators. So 1/2 times 3/4 is 1 times 3, which is 3, and 2 times 4, which is 8. Alright, so let's move on to division. We know 3 divided by 6 is 2. I'm purposely putting it over there for a reason. We're going to express our answer as a fraction again. So let's see if we see a connection here. 6 divided by 3 is the same thing as 6 over 3. Which is 2/2. But what's the connection here? This seems to be a little odd. 6 times 1 is 6, and 1 times 3 is 3. So this is really the same thing as 6 over 1 times 1 over 3. 6 over 1 times 1 over 3. So if we flip this fraction over and multiply, we get the same result. That appears to be a visual connection. We're going to try and make sense of it in a bit. Alright, so let's take a look at another example. We're dividing by a negative, so if these are different, we should get a negative result, so this should be -2. Just to confirm that with the calculator. That's -6. Oh, not -6. 6 divided by -2. Whoops, that wasn't supposed to go there. -2. -3 should be equal to -2. Okay. And similarly, that's -2 over 1. That's 6 over 1 divided by negative 3 over 1, so we can write these as fractions so we can see if we have a pattern here. So that's 6 over 1 times 1 over negative 3, which is equal to 6 over negative 3. And 6 divided by negative 3 is negative 2, so we get the same answer. Same thing here. That is also negative 2. Two negatives should make a positive. Let's see if the trend follows. So that's negative 6 over 1. 6 over 1, negative 3 over 1, times 1 over negative 3. So that's equal to negative 6 over negative 3. And negative 6 divided by negative 3, that's 2 negatives, so that makes a positive. So that is 2, or 2 over 1. So division is equal to multiplication by what's known as the reciprocal, where you flip the fraction. Alright, now I had this box here for use for explaining a way to figure out a bit about division. We might look at that in a moment. Alright, so let's take a look at this last example. What is 0.5 divided by 0.75? So let's use a calculator for that. 0.5 divided by 0.75 is equal to 0.666666. Alright, now this is repeating. This is 1/2 divided by, that's 3/4. And as we've seen in previous videos, that's 2/3. Is this true? Well, based on what we've said so far, that's 1/2 times 4/3 should be equal to 8. I'm sorry, not 8. How did I get 8? 4 over 6, which simplifies to be 2/3. So this does appear to hold even for non-integers. Let's take a look at the definitions or the rules that have been written. In order to more easily divide a number by a fraction, excuse me, I write these things in advance and I forget to proofread. In order to more easily divide a number by a fraction, multiply by its reciprocal instead. For instance, 1/2 divided by 3/4 is equal to 1/2 times 4/3, which is equal to 4/6 or 2/3. So it's the same thing. Alright. Now, just like we looked at with addition and subtraction, there are the same two rules for multiplication. And that is the commutative property, which says the order of the numbers can be reversed. It doesn't matter the order in which we multiply these numbers, we'll get the same result. In this case, 900. We have a bit more time in this video, so let's see what we get if we multiply these. 5 times 10 times negative 6 times negative 3, we get 900. If we switch the order around, you'll notice that the signs are coming with all of these numbers. That's important. Move them back there. If we have negative 6 times 10 times 5 times negative 3, we also get 900. So the order of the numbers we multiply doesn't matter. We can switch them around as long as they maintain their signs. The associative property, as you can see from the basic rule, is that you can do these in any order. We can multiply b by c first, then by a, or multiply a by b first, then by c. So we can multiply any two terms in a string of terms in any order as long as you maintain their signs. So let's just pick two terms to multiply by. 5 times 3 that's negative 15. So rather than, let's bring down to negative 6 and the 10. Now we could multiply the 15 by the 6, but it doesn't matter. We're just going to do the 6 and the 10 first. That's negative 6d times negative 15. And if we multiply those, negative 15 times negative 60 should be 900. Two negatives make a positive. So that's 900. So I didn't do these in the direct order that's here.